So let's talk about forecasting. I mean, it sounds like a superpower, right? Predicting the future. But really, it's a skill. And just like any other skill, whether you're building a cabinet or cooking a meal, it all comes down to one thing: having the right tools for the job.
It's the big question, isn't it? For literally centuries, we've been trying to figure out what's coming around the corner. The weather, the markets, next quarter's sales numbers. But the answer isn't some mystical crystal ball.
Nope, the answer is a toolbox, a forecaster's toolbox, packed with specific instruments that are designed to find patterns, measure data, and ultimately build a really reliable picture of what's likely to happen. So today, we're going to pry open that lid and get you started.
Okay, so here's our plan. We'll start with the absolute basics, understanding your raw materials. That's your data. Then we'll get into how to draw the blueprint, which is all about visualizing that data to really see its shape. After that, we'll get precise with the art of measurement. And finally, we'll cover maybe the most important step of all: quality control. To make sure our work is actually solid.
First things first. Before you can build anything, you've got to know what you're working with. In forecasting, your raw material, your wood, your steel, your concrete, is data. And understanding its properties is absolutely step one.
The most common material you're going to work with is called time series data. Now, let's break this down, because there are three key parts here. We've got comparable measurements. That just means we're measuring the exact same thing each time. Then there's a single variable, like the sales of just one specific product. And finally, over multiple time periods. So day after day, week after week, you get the idea.
And, to make this crystal clear, let's compare it to its cousin, cross-sectional data. A time series follows one thing through time. Think of it like tracking the weekly sales of a single store. Cross-sectional data, on the other hand, is a snapshot of many things all at once, like the sales of 100 different stores, but all on the same day. Basically, one is a video and the other is a photograph.
All right, time for a little pop quiz to see if you're with me. Let's say you're tracking the weekly sales of refrigerators, but you're only looking at one specific store. What kind of data is that?
Yup, you got it. That's a time series. You have one variable, refrigerator sales, at one unit, that single store, and you're measuring it over multiple time periods, weekly. That is a textbook time series.
Okay, ready for another one? How about this? You pull a report with the credit ratings for 1,000 different people, all from today. What have you got there?
Nailed it. That's a perfect example of cross-sectional data. It's many different units, all those consumers, but at a single point in time. That is the photograph we were talking about.
Just a quick word of warning, though. Your raw materials, they aren't always perfect. You got to be on the lookout for weird issues. Like, are all your monthly periods the same number of days? Did someone change how they measure sales halfway through the year? These little glitches can completely mess up your forecast if you're not paying attention.
Okay, so we understand our raw materials. Now it's time to pull out our next tool, the blueprint. Before we can even think about predicting the future, we need to see the shape of our data, its structure, all its hidden patterns. And for that, we turn to visualization.
Forecasting isn't just guesswork. There's a pretty standard workflow. First, you collect your data, then you prepare it, which usually means cleaning it up. After that, you do some descriptive analysis to understand it, and only then do you get to the final step, predictive analysis. For our purposes today, we are zeroing in on that third step, descriptive analysis. This is the really cool part, where you use simple charts and summaries to turn a boring spreadsheet full of numbers into an actual story. And the most powerful tool for this is the time series plot. I love this analogy. Think of it as an X-ray of your data. It's so simple. You just put time along the bottom on the horizontal axis and your variable, like sales or website visits, up the side on the vertical axis. Instantly, you get a visual feel for how your data behaves. And this just nails the point perfectly. If you're just staring at numbers in a table, you might miss everything. But plot those same 62 weeks of sales on a chart and boom, suddenly you see the rhythm, the spikes, the dips. The whole story just comes to life right in front of you. So for example, if you plotted the number of calls to a health center, you could instantly spot things a table would never show you. You'd see that spike during a big flu season, the dip around Christmas when everyone's away, or even the weird blip from a long holiday weekend. Your blueprint suddenly has real-world context. So, you've seen the big picture with your blueprint. That's great. Now it's time to pull out the precision instruments from our toolbox. This is what I call the art of measurement, where we use specific numbers to summarize and describe what we've already seen. And to do that, we need a few key terms.
An observation is easy. It's just a single data point. A parameter is the true value for the entire population, like the true average sales for all stores everywhere, which, let's be honest, is something we can pretty much never know. So that brings us to the most important one for us, a statistic. A statistic is a value we calculate from the data we actually have. Things like the average, the minimum, the maximum, those are all statistics. They are the real-world measurements we use to try and estimate that unknowable parameter.
Let's put that right back in our toolbox. A statistic is your measuring tape. While a graph gives you the overall shape, a statistic gives you the hard numbers. It's the tool that lets you say, hey, on average, we sell 50 units a week, or our sales grew by 10% this quarter. It takes that visual story from your blueprint and gives it precise, concrete dimensions.
All right, we've got our materials, we've drawn our blueprint, and we've taken our measurements. Now, for the final and I'd argue the most critical part of any project, quality control. How do we actually know if the thing we built is any good? And I really can't stress this enough. You can have the best data, the most sophisticated model in the world, but if you don't check your work, it's all pointless. This means comparing your forecast to what actually happened. Did you predict 100 sales and only get 50? Well, that difference is your forecast error, and we have to measure it. This is not an optional step. It's essential.
Think about it this way. Checking your accuracy is how you know if you use the right tools in the first place. If your forecast error is huge, it means your blueprint didn't match the finished product. Maybe a simple average wasn't the right tool for a business with a strong growth trend. Knowing your accuracy helps you go back to the toolbox and choose a better instrument for the next job.
So there you have it, the fundamental tools for any forecaster: understanding your data, visualizing it, measuring it, and of course, checking your results. You now have the starter kit, so the only question left is, what future are you going to try to build?